Hi there, this is video 119 and we are doing subsets and starting to do some review because we are almost done this little section on Venn diagrams and almost done the chapter on reasoning. So a subset is when one set is completely contained within another set. I looked at a whole bunch of different websites trying to come up with a really good definition for it. Yeah, the best I got. But you can see here that B is clearly a subset of A. Now let's just go through it. Nope. Pause the video. Do this stuff because this is not new, and then turn it back on. All right, so A has got 2, 6, 10, 8, 4, and 12. I know they're not in order. So 2, 6, 10, 8, 4, 12. Every time I don't put them in order, I feel guilty, so let me fix it. 2, 4, 6, really, 8, 10, 12. It's kind of embarrassing that I have to do that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yes, I count a lot because I am a paranoid mathematician. I really don't want to reshoot the videos, and I really don't want to teach you guys wrong, so I'd rather double check and fix it in video. All right, set B is 4, 8, 12. So you can see it is part. It is completely part of set A. Now, A union B. So I want everything in A plus anything that's new in B. So what did you just figure out? Yeah, it's exactly the same, right? Because B is a subset, everything in A already talks about B. And yes, so that is essentially the same as set A. A intersection B, what do they have in common? Yeah, it's set B. So beware when you do a subset that when you do the union and the intersection, you're just going to be talking about the whole sets, if that makes any sense to you. All right, the symbol for subset, by the way, subset is this sideways looking C and is written as, for this setup would be B is a subset of A. You always put the smaller one first. So if I had this, and this is D, and this is C, whatever that will stand for, this would be C is a subset of D. So this is always the smaller. Okay, it's always a subset. And the second one is the big one. So order does matter on this. Remember when we talked about intersections and unions, order doesn't matter. All right, so I guess I wanted to emphasize that. Poodles are a subset of dogs, which means poodles are a small group. Dogs is a big group because there's other types of dogs. Like my delightful lab. I don't know where she disappeared to. Okay, vowels are a subset of letters. Humans are a subset of mammals. And apparently I was hungry. Bannock is a subset of bread. A very yummy, delightful subset of bread. Just saying. With school being out so long, I am missing all the fundraisers that they used to have with some delightful fried bread. Sorry, look at my chops there. Okay, let's get back to math. How do I know what type of diagram to draw, right? Well, I showed you the option on the last video. Is you can start with every one of them, use a pencil, do an overlap, and most of the time you're probably going to be right. But that wastes a lot of effort. There's an easier way. What you do is you just take a look at your data. So 1, 2, 3, 4, 5, 9, 7, 6. Is there anything in A that's in B? No. So here's A. 1, 2, 3, 4, 5. And here's B. 6, 7, 9. Ta-da. Let's see what we got here. All right. Ooh, look, overlap. There's 1. The 3's overlap. What else overlaps? Yep. 6 overlaps. So 9 there. Oh, cool. 9's there too. All right. So everything in set C is also in this bigger set. So C has got 3, 6, 9. And this has, now, very, very careful. 4, 5, 7, 8, and 10. Make sure you don't write the 3, the 6, and the 9 again. You know, they only get numbers or variables or whatever it is, only gets to show up once in the diagram. Okay, so watch for that. These are already there. This is a subset. So it's part of this bigger one. And let's see what this one, we got 15 in common. I think that's it. All right, but all you need is 1. So here's E, and here's F, and you know what? I'm going to put the 15 in first, and then I got 5 and 10 and 20 in this one, and in this one I've got 3, 6, 9, 12, and 18, and 15 only appears once. So never, ever, ever, ever can you have a blank space. So you can't draw this one as an overlap. You can't draw, right? You can't do this and have 1, 2, 3, 4, 5, 4, 7, and nothing over here, right? You can't leave stuff blank. And because I was having so much fun doing this stuff on Venn diagrams, I actually looked it up. There is a guy, his name is John Venn. He lived in the 1800s and early 1900s. I can't remember exactly, but he passed about 1923. He was a British mathematician, and he's the guy that you can thank for this stuff. Cool. End of video.